Good morning. In this lesson, we will continue our chapter 14 from exceptions in Java. So let's start with the checked unchecked exceptions. Java throws checked and throws and handles the checked and unchecked exceptions. Basically, what is the difference between checked and unchecked is checked exceptions are handled or even checked during the compilation time. So that's the idea. Checked exceptions are checked during the compilation time. For example, if a method is throwing a checked exception, it should handle the exception, the method, then the method should handle that exception using a try catch block. If it doesn't have a try catch block, doesn't matter, it can declare the exception using the keyword throws. You remember how to declare the exception. Like for example, you're writing a method like void, and then the method name, for example, method name is, let's say, main method, and you have parameters, then you declare the exception, let's say throws, and after throws list what are all the exceptions it is going to throw, the method is going to throw. So that's the idea of declaring. Okay, so for checked exception, the method can, the checked exceptions are thrown during the compilation time, and it's checked during the compilation time, and the condition is the method needs to handle that checked exceptions during using the try catch block. This is the condition. Checked exceptions are checked during the compilation time. That's fine. So the method which is throwing the exception. So the method throwing the checked exceptions needs to handle that exceptions using a try catch block. It's not compulsory that you need to have a try catch block. So I don't write a try catch block. Doesn't matter. At least you need to declare the exception. Just now I write it on the screen how to declare it. You, in the method heading, you list the exceptions that method may throw. Okay, like void, that's return type, like public void method name, and then it has parameters. So after the parameters, in the method heading, the first line, in the method heading, use the keyword throws and list the exceptions the method may throw. That's called declaring exceptions. Okay, so this is about the checked. When you're talking about unchecked exceptions, it's the other way around. Unchecked exceptions are not checked at the compilation time, so that means they are checked during the execution time. For example, if your program is throwing an unchecked exceptions, and I didn't have my try catch in my program, or even I didn't declare that exceptions, so the program, it's not going to give you compilation error. Okay, so most of the time these exceptions occurs due to bad data, like the user is giving for the input, something like that. That's the idea. So this is, it's basically for unchecked exceptions. It's up to the programmer to judge whether this type of error may occur or not. I mean, this type of condition. Exception is a condition, is it? Like unexpected event. So the programmer needs to judge whether that condition may occur or not, etc. Maybe that condition may cause some exceptions. Then you can handle appropriately. Okay. So that's the difference between the checked and unchecked exceptions. Okay, one other kind of very simple example I can tell for unchecked exceptions. Do you remember I always say in the class, null pointer exception, array index out of bound exception, arithmetic exception, which is divide by zero. You divide a number by zero. So even null pointer, sorry, even number format exception, Number format means it needs a number, but you are giving some different data. That's the input problem. It wants an input, but you're giving a wrong input. I need an integer, you're giving a string. Okay, so that is number format. So these are examples of the unchecked exceptions. Okay, so it doesn't matter that you need to have a try catch block. Many of the time you might have noticed in your array program. So here, unchecked exceptions are the normal examples that we always get in our practical timing, like data structure or Java, which is null pointer exception, index out of bounds exceptions. Okay, so let's see. Checked and unchecked exceptions. Here Java throws class. So throws is quite different from throw. They are not similar. Okay. Exceptions of class error and runtime exceptions and all their descendants are called unchecked exceptions. The one I was telling, like null pointer exception, array index out of bound exception, they are all comes under the category unchecked exceptions. And the examples I'm giving, the null pointer, array index out of bounds, arithmetic exception, number format exception, they are sub descendants of runtime exception. Okay, and the remaining all other exceptions are called checked exceptions. For checked exceptions, this is what I was telling, that it can be you can write try catch block to handle that exception. Here it's mentioned you can have a try catch block, or else you can have a throws class in the method heading saying you declare the exceptions. telling the compiler that, yeah, these are the exceptions the method may throw during the execution time. So that's the meaning. So what else the other design choices? For example, let's say a method cannot declare more exceptions in its throws class, then method it overrides. You might have remember the idea of overriding superclass subclasses. A method in the superclass overrides the method in the a method in the subclass overrides the method in the superclass. Fine. So the subclass method, the overridden method in the subclass, the child class method, that cannot declare more exceptions than the parent class method. Okay, in the throws class, declaration of exceptions always comes in the method heading using the keyword throws class. Okay, a method that calls a method that lists a particular check exceptions in its throws class has three alternatives for dealing with that exceptions. So what are the three alternatives? So you just recall back the throws. In the method heading, you are writing the you are declaring the exceptions. That is the idea I'm telling throws. So let's say your method is a void method. So you write void and then you write the method name. Let's say the method name is get and then parameters. And then you write the throws. Throws. After throws, you list the exceptions like IO exception, comma, .NET exception, whatever exceptions, class not found exception, file not found exceptions, etc., etc. So you are going to list those exceptions after the throws keyword in the method heading. So after that, the method body starts the statements and then close the method. Is it? So declaring an exception means you are using the keyword throws and list those exceptions the method get may throw during the execution. So how the method is going to handle those? So there are three ways of like kind of handling that exceptions. So maybe it can catch and handle the exceptions, or else what it will do, it catch the exception and throw the exception. Okay, catch and then throws the exception, or else declare in its throws class and I'm not going to handle it. Okay, so either you can have I'm talking about the checked exceptions here in its throws class. There are three alternatives dealing with the checked exceptions. This is the one I'm discussing. So there are three ways of handling it, three alternatives or three ways of handling it. What are they? They are listed here. Catch and handle the exception using the try catch block. Catch the exception but throw an exception that is listed in its own throws class. Either you catch it but you're not handling it, you throw it. Catch and then throw it. Okay, this is what we discussed already. Is it like you catch an exception using the catch block, but catch block can throw an exception. This is the second one listed here, rethrowing. This is what we call rethrowing an exception. Catch the exception and then throw the exception. Okay then, and declare it in the throws class and don't handle it. Mean to say my method may not have the try catch block. I just declare it in the method heading. That's it. So that's the third one. Okay. First one is having a try catch. Second one, having the try catch. Catch has another try so that it can throw. Okay. And the third alternative is no try catch in my method. Just declare it on the heading. Let the JVM handle the exception when it occurs. So finally, class. So this is a class. It comes with a try catch. That's what you call finally. Where to put this in the try catches after at the end of the try block or try construct. Try comes with a catch. After the catch, you put the finally block or finally class. Okay. The idea of finally is this finally class will be executed always. That's the idea. You need to remember. What does it mean always? For example, there is a try. Okay, for example, you have the try. Okay, and after the try, you have catch block. And after the catch block, you have the finally block. Okay, fine. So finally, and then you have the bracket. Okay, let's assume in the try, I had an exception. There was an exception and it's caught in the catch block. So there is an exception, it's caught in the catch block, finally will be executed, of course. This is one situation. Okay, and there was an exception thrown here in the try block, but I don't have an handler. Handler means a catch block, the appropriate catch block. There is no handler bound to that exception, no matching handler. So it's not handled here. If it is not handled, the default handler, JVM will handle it. Even that situation, finally block will be executed. Okay, in case that I don't have any exception, there is no exception, and there is no handling, even though finally block will be executed. Okay, remember this is the idea of finally. So regardless of what happens in the try block, the finally block will always be executed. Remember this point. Okay. So this is one simple example where you can see the try block with the finally. Okay, one more thing I didn't tell you in the previous slide. It doesn't matter that finally block comes after the catch block. You can have this way. In the slide, can you see a try block? Try doesn't have a catch block, but try with the finally. It's okay. We can have this way. No problem. This is also acceptable. Don't expect that there is a catch block missing. It's an error. No, it's not. It's this way of writing the try is also fine. Okay, so here in the slide you see a try block with the finally block. Okay, so idea is the try contains a for loop for index 0, index less than 100, index plus plus. That means this loop will be executed for 100 times and there are some conditions, whatever is it. So after the try you have a finally class, finally block. Okay. So even though there is an exception in the try or no exception in the try, the the exception is handled or not handled by the catch. By the way, I don't have a catch block here in the slide. So in all situations, whether there is an exception in the try block that's thrown or there is no such exception, the try block executes smoothly. Even with whatever situations, the finally block will be executed. So the next is assertion. So the idea of assertion is it's a statement in Java that is used to test your assumption about your program. It's a kind of a Boolean expression saying the current state of the program. So Boolean expression means like A greater than B, that kind of expression. And the value of the Boolean expression, of course, it will be true or false. So if the expression is true, nothing will happen. If the expression is false, an exception will be thrown. Okay, like what is the exception? Assertion, error, exception will be thrown automatically by the JVM. Okay, only you need to give the assert statement. The statement goes like that. It's given in the slide down here. The syntax is given. So either assert with a condition or assert condition and expression. Okay, for example, let's see one example. You have a variable called age. So the condition is age greater than, for example, 15 and then colon. And then I say, let's say in a quotation, I say not eligible or eligible or something. I write a message, whatever message, then semicolon at the end. For example, I write a message here. May not eligible, eligible, not allowed, allowed, whatever, I don't know, whatever message. So during the execution time, when the condition becomes true, nothing will happen. the procedure. So the execution goes to the next line continues. Let's say your age is, for example, 10. 10 greater than 15, condition not satisfied. So this message will be used in the display of the exception. When there is an exception, it will show a long history of message saying the mistakes, error, or whatever situation. So your message, what you put it after the colon, this message will be displayed in the assertion, error, exception, the stack trace, the exception stack trace. The message will contain your string. This is string. This is the idea of assertion. By the way, Java allows us, you can include assertion in your program, doesn't matter. But by default, execution of the assertions are disabled by Java. Even though you write assert statement in your program, it will not be executed because by default assertions are disabled. But you can enable it in case if you would like to include assertion in your program, you can enable it before the execution. So let's see the exceptions, evaluations. The types of exceptions makes more sense than in the case of C++ when you compare, because we discussed too C++ and Java. So here the exceptions, what are all the exceptions you have here? You have varieties of exceptions, null pointer exception, IO exception, etc., etc. Okay, that makes more sense when compared to C++. And throws class is better in Java than the C++. Finally class is also useful because let's say sometimes you want to do something, you want to run some statements, no matter there is exception, there is no exceptions, whether exceptions caught by the handler or not caught by the handler, in whatever situations you may have some statements to be executed always. So in that case, you can use finally class, you put your statements in that. So whatever happens, the finally class will be executed. So obviously, finally class is more useful. So Java interpreter throws varieties of exceptions that can be handled by the program. Let's say if you write a catch block, your catch block handles the exceptions that's thrown. Now let's move on to the event handling. So event handling is, let's say there got some event and it listens for the event and then it triggers an action. So that's the idea of event handler. So event is a notification of that something has happened. What can be something, maybe a mouse click or mouse double click or moving the mouse, like hovering the mouse over a button, or like key press, like enter key, or key move the key down. When you press the key will move down. That also can be an event. Let's say you release the key, let's say you take your finger out of the key will move up, key down, key up. So these can also be a event, whatever, not only pressing the enter key, even the key down, key up can be a event. Mouse click, one click, double click can also be event. Hovering, moving the mouse, and then dragging the mouse, dragging. So there are many events possible. So these are, event is a notification that something has happened. That's the event. Okay. And every event has a handler. So that event handler is a program, small set of program statements, a segment of program, a code segment that's executed in response to the event. And there is a mouse click, that the event handler for the mouse click will be executed. Okay. So GUI components. What are the graphical user interface components? Java Swing GUI components. Text box, it's an object of a class JText field, and you have a radio button. It's an object of the class JRadio button. Applet, you remember, maybe you remember in Java 2 you studied J-frames. Applet is a kind of, you will have a feeling of the J-frame, okay, but it's a little different. It's a multi-layered structure, okay, but it's very close to J-frame. Java string has JFrame, okay, the container, it's very close to the JFrame, but it's multi-layered. Okay, content pan is one layer that there you put all your components, okay, where your applet put the output or whatever. Okay, GUI components can be placed in one frame, and layout manager tells you the arrangement of the components, like what should come on the top, bottom, like north and south and east and west, or like in a grid manner or what. So that's by the layout manager. So Java event model. So user interactions with GUI components create events. Okay, like a mouse click. You click a button or you press enter. When the button is enabled, you press enter. Or not even button. When you click a text box, when you click a label box, you that's the event. That's you are creating the event, and that will be caught by the event handler. Okay. So that's there you have a event listener. So event generator tells listener that an event by sending a message. Okay, the event generator tells the listener how it sends a message to the listener. An interface is used to make a event handling methods. Okay, there is an interface that enables you to create event handling methods. Okay. So the class that implements a listener must implement the interface for the listener. Okay. So there is a listener for the handling, sorry, interface for the handling and interface for the listener. Okay. Let's assume there is a event called item event. Okay, what is this item event? Item event is associated with the buttons, like the components, items, like clicking a checkbox or radio button or list items. Okay, because that contains list of items. So that's what you call item event. Like a radio button may have so many items. So you will be choosing an item. Checkbox, you will be choosing an item in the checkbox. And list may have sub list, a collection of items. You will be picking one item, is it? So whenever you deal with items in the checkbox or radio button or a list item, so this event will happen. Okay, so there is an item listener interface, and it prescribes a method. What is the method called? Item state changed. The state of the item got changed. So which is a handler for the item event, item event events. Okay. The listener, how do you create the listener? You create the listener with add item listener. So you are going to create with that one. Like you in Java 2, you might have studied action event and then action performed. That are all for the mouse action, like mouse click, mouse up, mouse down, hovering, dragging, moving, mouse move. So that's for all action event. This one is item event. The one in the slide is talking about item event. Okay, so every event, just remember that event we need there the event producer. I mean to say there is a event generator. That generator will make a signal to the event listener so that the action or it's not an action. The handler will be triggered so that the handler will be executed. Every event is associated with a handler. So in between there is a listener. So when event generator generates the event, listener will be notified, and listener is the one makes the handler to execute. Okay, so that's the idea. There is an interface for every type of events. For item event, the listener is item listener. And where is it? It's in the interface, item listener interface. Okay, and the method is for the action. For the action means for the handler, that's called item state changed. That is the, you need to write the method because it will be an abstract method. You need to implement the method in your class. Item state changed method. Okay. And whatever statements you put it in the item state changed method, that will be executed when there is a event. So this is the end of chapter 14. So here we discussed two main things, which is exceptions and event, exception handling and event handling. Thank you.